Hello students, we are going to be dealing with implicit differentiation in this video, and I want you to pay attention closely to really understand the intrigues, the concepts, and the methods of solving uh, differential calculus, that is implicit functions like this. Now, how do we go about this? Now, I want you to have a reminder. Remember the rule in differentiation. If you have y is equals to x squared. All right, if you're going to differentiate this, or let me put it x raised to power n, right, so that we have a more generalized function. Now you have y is equals to x raised to power n, and you wish to differentiate to get your dy by dx. What do you do? Now this is the definition. We're going to have n, then x into n minus 1. Now this is a standard, this is a general method of differentiating functions. Now, but you see, this is an explicit kind of function where it is well defined. Now, the meaning of explicit is that it is well defined. You will have y is equals to anything function of x. Now, but in this case, where you are going to have both the x function and the y also being a function in that particular expression, then we call it an implicit kind of function. And this is how we are going to like differentiate it. Now, I'm going to be telling you some simple rules or simple guidelines you need to know or you need to get pertaining this. Now, if I'm going to work this out, now this is what I'm going to do. Now, I'll pick the first. I'm going to pick this. Now, I have 2xy squared to differentiate. Now, there are two things here. I can decide to actually pick 2 as my coefficient, which I'm going to have x, then we have y squared inside, like this in the bracket. Now, in differentiating this is my 2, which is a coefficient. Now, if you check, in this case, like I said earlier on, both x and y are all functions that we can actually differentiate. And now, since x and y are functions, now we have two functions multiplying themselves. Then we move to product rule. All right. Now, in product rule, remember, we are going to pick one, we'll keep it. So I'm going to be picking x, I'm going to keep in x, then I will differentiate y. Now, I will treat y as a normal variable to differentiate, so that when I differentiate y squared, I'm going to have 2, then y. Remember, it's going to be 2. Remember, it's supposed to be 2y raised to power 2 minus 1, which is the same thing as 2y. Okay, so take note of it. But the simple rule in implicit differentiation is this. Whenever you differentiate y, it's going to be accompanied by dy by dx. All right, so we keep it. Then plus, I am going to keep y squared. Remember, don't forget, this is product we are dealing with. Then I would differentiate what I actually kept in the first instance, which is this x. Once I differentiate it, I'm going to have 1. Okay, differential of x is just 1. Remember, 2 multiplies everything, so I'm going to have 2 into, I have 2xy dy by dx, then plus y squared. Okay, now once I expand further, I'm going to have 4. I'm going to have 4xy dy by dx, then plus 2y squared. This is what I'm going to have. Now, but remember this. Some other people might not follow this process. This is what they are going to do. They will pick the 2y, the 2xy squared. Then they will now keep 2x. That is very direct. I'm going to keep 2x. Then I will differentiate y squared, which is going to be 2. Then I have my y. Then dy by dx. Then plus, then you keep 2x now. Then you differentiate. Sorry, we are not keeping 2x again. I think sorry, this time around you are keeping your y squared, then you differentiate 2x, which is going to give you 2. Now once you expand it further, you're going to have 4xy dy by dx, then plus 2y squared. If you check, the same thing. So it depends on what how you want to do it, how you wish to do it, but this is the explanation. Okay, then let's move to the next term. The next term is x cubed then y. Okay, now to differentiate this is what's going to happen. I'm going to keep my x cubed, then I'll differentiate my y, which is going to be dy by dx. Now some people will like, why am I just putting dy by dx? Actually supposed to be 1 then dy by dx. Okay, then plus I'm going to keep my y, then differentiate my x cubed, which is going to give me 3x squared. So putting them together, I'm going to have x cubed dy by dx, then plus 3yx squared. So I'm done with the second. Now the last, which is going to be 4x, differentiating, I'm just going to have 4, okay, as the differential. Now I'm going to differentiate. Okay, the last one, which is a constant term, differential of a constant term is 0. All right, so I've differentiated all the terms one by one. I'm going to bring them together. Now the first one is this: 4xy dy by dx, then plus 2y squared. Then I'm gonna have a plus x cubed, okay, then plus this, and which we've differentiated it to be plus, I'm gonna have x cubed dy by dx, then plus 3y x squared. Then remember, this is minus 4x, so it's going to be minus 4 as a constant, as differential of 4x, then is equals to 0, which is differential of the constant term. Now recall that all our aim in this case is to get our differential dy by dx. Now we are going to collect like terms, so that I'm going to have 4xy dy by dx, then plus x cubed dy by dx, then is equals to, I'm going to pick this and this over the equal to sign, so this becomes minus 3yx squared. Then I'm going to have minus 2y squared. Then the last one here, I'm going to have plus 4. Now we're moving. So therefore, I'm going to I'm going to factorize dy by dx in the left hand side, where I'm going to have 4xy plus x cubed, close the bracket, is equals to here. Let me rearrange it. I'm going to have positive 4 from the beginning, minus 3yx squared, then minus 2y squared. Everything is taking shape. Now, for me to actually have my dy by dx, I'm going to take this out by dividing through by it. All right, so I'm going to have dy by dx is going to be equals to 4 minus 3y x squared minus 2y squared, then all over 4 xy plus x cubed. Now this is our answer. This is what we hope to get, and this is what we've achieved. So therefore, the differential, the implicit differential of this particular expression is 4 minus 3y x squared minus 2y squared all over 4xy plus x cubed. Thank you so much. You can go over the video, make your comments, and over, and I think you're going to have a very good understanding when you go over it again and again. So thank you so much for watching.